Good morning and good afternoon, everybody. Welcome to this presentation. I am very happy to introduce my co-presenter, Ganesh Nakwa, the VP of Product Management at our company, Avocado. I am Joseph Feynman, Chief Strategy Officer at Avocado. The subject of today's presentation is application architecture and threat modeling. This is a very important subject. Avocado is broader than just application and threat modeling, but it's one of the very important features, and I would be happy to introduce it to you. First of all, what is this architecture and threat modeling? It is a proactive way to understand the real architecture of an application and detect vulnerabilities, and do this before you roll application into production. This is critically important to do observability into real architecture. And I highlight word real here because it's not necessarily the threat model that we build is a realistic reflection of what's happening with your application. Then we need to conduct risk assessments of an application itself, but are they moreover not an architecture of an application itself, but an architecture of an entire application and API ecosystem, because one application calls another one service calls another one, and you need to understand how they work together. And therefore, you have to construct an architecture with appropriate security controls. This is critical. So in the time of building your application, you introduce in your architecture appropriate security controls. So when your application is ready and rolled into production, those security controls will take care of your application security posture. And you have to be doing this before application deployment when cost of fixes is very low. There are different research that tell you that if you detect the very same vulnerability in production, post deployment, then to fix it would cost you 100 times, not percent, but 100 times more than had you detected it previously at the beginning of your application life cycle. So we understand the importance of architecture and threat modeling. Let's reference Gartner. Gartner ranks all its technology on the scales from low importance to moderate importance to high importance. Gartner gives high importance score to architecture and threat modeling. So the question is it really well adopted? And the answer is no. The adoption is low and poor. I believe by same Gartner assessment is somewhere between 20 to 50% of all organizations, which means let's say about 35%, about only a third of organization adopted architecture and threat modeling. And they are not doing it for all applications. Typically, it's for one or for very few select applications. So we need to understand, first of all, what are the problems with the architecture and threat modeling. And there are numerous problems that these methodologies are facing. First of all, this process is largely manual. It's based on questionnaires and surveys. The architecture specialists or security specialists, they're going around and speaking with people and trying to understand what kind of module, what kind of service they're building. And if it's a database access, well, they think that we should check it for vulnerabilities such as, or attacks such as SQL injection. And if it's a login into your banking system, then you have to check it with identity and access management, which is very imprecise and very resource consuming process. And that it involves a variety and multiplicity of individuals. You need to talk to business owners of an application, and with architects, and with programmers, and with operations specialists. Once again, it increases the duration of building it. So building the model and updating it requires an acceptably long time and very substantial use of resources. We have clients that complain that it takes them about 60 days, 2 months to update an existing model. That's how long it takes. And one of the most serious obstacle to adoption is the input into the model with the traditional tools is based on theoretical assumptions. It is based on what this questionnaires and survey says, what your business people and architects and programmer think of the future application, of course, which impacts immediately your model and makes it from the beginning inaccurate. Are there automation tools for threat modeling? Of course they exist. This space has been in existence for, I would say, 15 years. But what they do? Well, they typically make your model diagramming faster so you can rapidly build this logical blocks one after another and connect it with a different kind of errors. It is a help, I wouldn't object. But the problem is it is the same principle of building model. It is based on assumption. It doesn't make input realistic and accurate. And then it offers security controls and fixes that are generic, not specific, because it has difficulty to understand the real state of an application. Very unfortunately, the standard approach prescribed by threat modeling tools today starts with these words, draw your diagram. And that is where your inaccurate application and threat model starts. It should be changed. And I want to introduce you a solution offered by Avocado Systems. We're offering a groundbreaking approach that is runtime, on-demand, application architecture, and threat modeling. It's based on four principles, our technology. First of all, it's a runtime technology. So in runtime, we plug into the running application and we have complete observability over the architecture, the real runtime architecture of your application, all connectivity, all calls, all connections, all threads at build time, at pre-deployment, where you're still building and testing your application. So we observe that application, its architecture, the way it really is, not what your people, your developers or architects think it is. That is runtime capability, runtime principle. Another one is persistency. We endlessly, continuously collect all application artifacts and API artifacts and data exchanges artifacts, and we have complete and continuous observability of a threat landscape. So we can observe architecture and threat model at any moment on demand, and we can request. And my colleague Ganesh will show in just a couple of minutes how we do it on demand creation, a snapshot of an architecture, and you can immediately see what is really happening and what threatens your application. And we have a complete observability into application and API, into inter-process calls, into all data exchanges, because we're in the full control of these calls and we see the call in its entirety, including every single byte and bit of the data submitted. And of course, we detect and see security vulnerabilities. The last principle upon which our technology is based is autonomous architecture and threat modeling. It requires no or at least minimal human involvement. It does not require any collection, any manual collection of API artifacts or application artifacts or security artifacts. No questionnaires and surveys. It's autonomous approach and based on runtime capability and persistency and observability and autonomy, we offer this groundbreaking experience. Let me show you how it fits into the portfolio that Avocado offers, and then we'll go into the live demo of our technology. Our product, I believe, is simple and elegant. It consists of two products, Avocado Reveal and Avocado Protect. Let me show them from the perspective of the DevOps, where in DevOps we apply our modeling, and from the viewpoint of observability and ability to protect. The technology, the product that observes and diagnoses architecture and vulnerabilities in pre-deployment and then in operation is called Avocado View. And what it does first, it offers that runtime continuous persistent observability into applications, into all APIs. You cannot escape us detecting your APIs, observability into processes and into data exchanges. It offers this architecture on demand at any moment. You don't need to wait 60 days. You can do 6 models in one day. That's so easy and so fast. We offer runtime threat modeling, and of course, we offer runtime detection of application and security vulnerability. And then, and only then, when you have this complete insight, most accurate model of your application, API, security threats, and vulnerabilities, you can protect with our technology, with a product called Avocado Protect, that of course is based on the same runtime observability and ability to completely get application architecture model. It enables to protect against any kind of attacks, including zero-day attacks, attacks where principle of using signatures and patterns is unapplicable. We can stop all these malicious processes, and we have a subproduct of Protect called Avocado Encrypt that enables to protect your unprotected sensitive data in real time. So application architecture is a part of the portfolio, and with that, I pass the microphone and the camera to Ganesh.
Thank you, Joseph. Um, when you're working on app threat modeling, you're actually trying to improve your security within your environment. Whether you're a DevOps or SecOps person, you want to improve your security. The first thing what you need to do in this process is to identify asset and their dependency. How your applications are connecting to each other, that's very important, right? And then second thing is, how do you identify trust zone, whether your web application should talk to database server or any other BI server, whether your data is encrypted or not. Do you have a latest encrypted TLS encryption or not, right? Those things are important as well. During that process, you can identify those information. And the third one is, once you have this information, then you're more focusing on identifying threats and vulnerabilities associated with those applications. And the last one is documentation. Documentation where you can generate different reports, and based on historical reports as well as a current report, you can see the drift, how your applications are behaving in real time environment. And based on that, as a developer, you can analyze those, you can troubleshoot, and you can fix those issues also. So you can have like a mitigation plan based on the reports that you generate with this model. So how Avocado helps by providing runtime API app security observability, which gives you more insights on real architecture and security posture for your environment. So in typical like API or app architecture, as you can see on the screen, right, this is from AWS, it can be Azure, it can be GCP, or it can be on-prem. It has semantic functional blocks. However, it may not have the API details or database related details, right? It may not have threads associated with those applications or APIs or vulnerability information. And you don't have interaction from outside APIs or outside application, how they're interacting with your inside application. So, you may lack in a scale out architecture detail with the current model. So that's where Avocado helps customers with application architecture model, where you can see all processes, runtime functional processes in one screen. Whether you have one process or 1,000 process, you can get the layout of how your applications are talking to each other, details of any API call or data exchange happens, or whatever services they are accessing, right? We are not just showing the applications connections where how they are connecting to each other, but we also provide thread and vulnerability detail. That gives a complete picture of not just application behavior, but also what kind of threat associated with those applications. And we can provide third-party APIs or any other dependencies that we have, we can show in that application architecture. It's very easy to use. It comes with HTML format. You can open in any browser, and you should be able to hand it over to developers, and they can take that and analyze offline as well. So it's a very scale out model. And I was talking about vulnerabilities and threats, right? We can detect runtime threat vulnerabilities, and we can classify and categorize that. As you can see from that picture, we have shown top vulnerabilities. We can also show top vulnerable applications, and so on and so forth. I'm going to go more detail on that in demo. But this is a snapshot of a runtime architecture and vulnerability posture. As you can see from the screen itself, right, you have unknown client. This client can be browser or any other server. They're trying to reach a Java application. And Java application, if you hover it, it shows all detail about Java application, right, from IP address to application path, and then how Java applications are talking to other server, whether it's SQL database or any unknown server that this Java applications are trying to talk. So basically, it will show the trace path from source to destination, right? If I'm a developer, I wrote the software, and I'm gonna focus only on the application which I developed. So you have flexibility where you can hone in on one application, and you can see the trace path from that application. And on the right hand side, you see all threat vulnerability information, whether it's OOPS top 10 or proprietary or even customized rules that you use. Based on that, we can provide those vulnerabilities as well. So I'm going to show demo. In that demo, I'm going to cover application discovery and architecture modeling. And then I'm going to talk about how there are interdependency of processes across the tiers, and then API and stored procedure calls, and also vulnerability associated with each module. One important thing I want to show is, like, based on historical data, how you can find the drift associated with your application architecture. So let me share my desktop. Give me a second.
Not yet.
Yeah, I'm sharing my desktop.
Yes, we can see it. Thank you.
Okay, excellent. So this is our user interface, and this user interface is very intuitive, very easy to use. With Avocado solution, we have two major components. One is plugin, which is very lightweight software, kind of like a DLL file, which become part of your application. You don't have to do any instrumentation at all. Once you enable it, it will capture all telemetry based on security controls, and it will send that telemetry data to orchestrator. And orchestrator is a single pane of glass where it operationalizes all your application, right? As you can see, we have a concept called domain and subdomain. So a domain is one logical area where you can have multiple subdomains. Suppose if you have like a HR department, you want to have like a certain application servers group in that HR department, then you can do that in subdomain. And I'll show you how it look like. So this is my business portal subdomain, and I have many applications here, right, from Java to Mongo to MySQL, right? So as you can see from the dashboard itself, we have detected like a couple of threads on specific domains. And if you want to drill down, you can see more detail, and I'll show you in a minute. But now I have observability already, right? I know exactly how my applications are talking to each other, but I need to generate now report to see how it can, show me from diagram perspective and what are the vulnerabilities associated with that. So what I'm going to show you is a couple of things. One is I'm going to generate a report based on historical data, and then I'll also show you how the drift you can detect based on historical data. So in reports, if I select report, say application model, and you can see we have many reports that you can generate, application detail to forensic to top 10 OOPS category. But I'm focusing on application model, and just say last quarter, I'm going to get like all historical data for last quarter, and I'm going to select my domain subdomain here to collect the data or generate the report. As you can see from the screen, we have different options. We have Avocado's default, which is more detailed report. Then we have application architecture model, which is Avocado application architecture model. But we also have capability to create automated threat modeling for Threat Dragon Plus Plus, Microsoft TMT, and so on and so forth. So we can provide JSON file to those tools, and then they can generate application architecture model. So now I'm gonna generate application architecture model based on one quarter, and it takes a few seconds to generate report. So report has generated. Once I click it, it will download the report, and I can open this report in any browser. So now I have report. In this report, you can see I can zoom in, zoom out. If you have like say 1,000 applications processes, it will show all in one screen. One important thing to know is we talk about trusted zone, right? This is the domain where, this is my trusted zone, and I have different applications which I discovered, right? And also I can see the relationship, like how unknown client, whether it's a browser or some other unknown application that are trying to reach out to any applications such as Java in this case, right? And then how Java application is talking to other. So you get in one screen the whole layout of all applications and how they will interact to each other. So if you want a quick, you may have like many application processes, and you want to quickly find out, okay, I want to search for, say, Java_5, right? Based on application name, based on CWE or CVE type of information, you can find out or pinpoint that particular application. And as a developer, I can just focus on that, and then I can see the interaction with that application. As you can see on the right-hand side, we show top vulnerabilities, whether it's a cross-site script or others where you have Log4j type of attack. And you can see we have severity, CVE type of information. It shows summary. Also, it shows what kind of data we match. In this case, it's a Log4j attack, so we detect like Jindy stream in the payload. So that level of granular information we can provide. If I double click on that particular application, it shows me the path where it's coming from, the unknown client. If I hover it, it shows me the IP address of that unknown client. In this case, it could be a browser that are trying to reach out to Java application. And there's also curl application trying to reach out to Java application. So there are some curl command that been executed. So we capture all that information here. Now we have the data for like last 1 quarter. Now I'm gonna show you how drift you can determine with this data. So let me generate the report, similar type of report. So now I'm gonna focus only for last month, okay? And then I select this domain, subdomain, and generate a report. It takes few seconds. So once I generate report, I'm gonna see those reports. And as you can see, it is a little bit trimmed down data. So, developer may change the code, or they put some restriction, and they solve some of the vulnerabilities, right? So whenever it happens, we will capture everything. As you can see from old model, Java is connecting by unknown client as well as curl, right? Here, you can see your Java application is only talking to, or unknown client is reaching out to Java application. There's no curl process, right? So you can see the drift, how, from 1 quarter to last month's data has changed, right? So, and you can generate this report on demand whenever you need to find out the detail. Now I'm going to show you the report that you generate for third-party tools such as ThreadDragon or any other threat modeling tool. So I can go to same report and I can generate, say, last quarter and domain, same subdomain, and I can select now ThreadDragon. So here we can generate the JSON file. And once I generate JSON file, I can click that, I can download that. So this is the file, 73 etc. So I'm gonna open ThreadDragon here. So ThreadDragon, I can upload that file. And I can create the model out of that. As you can see, the model, the diagram has generated. And if I double click, it will show me the model. It has more details about how your applications are talking to each other. If you want to see more detail about that particular application, you can just highlight those, and then you can see the description about that application. It's a similar concept, but one thing we notice is when we use third-party tool, like if you have like a mini application, then it doesn't show in one screen properly. If you want to generate report, for example, if I generate report here, it shows that report, okay, I have diagram with all processes connecting each other, but then that information that as a developer I want to refer is not intuitive. And that's where, like, our application architecture, it's very easy to use for developers. They can just focusing on their application and they get their information, what they need, and they can mitigate those risks. So that's ThreadDragon. Now, I'm going to show how we can detect the runtime vulnerabilities, right? Runtime vulnerabilities. So here is my dashboard where I have 3 different domains. Portal R is basically for reveal, only observability. We are not gonna, this demo, we are not gonna do protect. However, I have protect as well as other domains also. So I'm going to show like a Log4j attack. As you probably know, Log4j attack happens when attacker tried to inject like a Jindy type of string into one of the application, like Java application, and then Java application can make the callback to external LDAP server, which is already malicious server, and that LDAP server can send malicious code back to your application. That way, hacker can get into that shell, and they can delete or exfiltrate data however they want, right? So here in this example, what I have is I'm listening on LDAP port, which is on 1389. So this is external malicious LDAP software. And then I'm also having a second console, which is nothing but attacker console, where I can use any command to execute or exfiltrate or delete any data, right? So what I'm going to do is from browser, I'm going to send the Jindy string. So what happens is as soon as I send the string, it actually exploits the attack, right? As you can see on the LDAP server console itself. And once the attack is exploited, you can see here, we can also discover that on one of the domain. In this portal R domain, it's already detected that attack. And as a hacker, I can get into shell and I can just type in ID, who am I got now root access. So with root access, I can find out information which I want. If I want to download any software, I can quickly download this as a wget software. Right? Once I get wget software, and if I want to get in google.com, I can do that. So now we are just observing everything, right? Attack has happened. We have detected in UI. Now I'm going to generate a report which shows actually how the attack has happened. Okay. So I'm going to go to reports, select application model here, and then I'm going to select today, my domain, in this case, portal R, and enterprise billing. And then this is the architecture model, which I'm going to generate. As you can see, it takes few seconds to generate report. Now I have application architecture model. As you can see from the diagram itself, right? This is the unknown client, which I showed you from browser, right? They're trying to reach unprotected Log4j application, which is nothing but Java application, as you can see from the information itself, right? And if I want to highlight or double click that, then it shows me the path, right? And the path is like, it's trying to reach out that Log4j application to external LDAP server, which is listening on 1389. And then as a hacker, I have now access to reverse shell, right? And as you can see, we downloaded wget software, and it has a link with external server, which is google.com. So you see the exact, like a real-time information from that architecture model. And if you want to see the details about that particular vulnerability, you can see here we have detected the Log4j attack, and it has CV information. If you don't have CV information as well, like in case of zero-day attack, with our ring fencing, we can detect that and we can block that. But here, in this case, we are showing this Jindy string, and that way, as a developer, you can find how my applications are behaving in real time, and I can generate report whenever I want on demand basis. So that's it from my side. I'll hand it over to Joseph. Joseph, over to you, please.
Yes, thank you. If you stop sharing the screen, I can get to the slides. Let me get to the next slide. Thank you for that demo. I've seen it many times, and every time I enjoy it, and every time I really see what the power of this runtime on-demand architecture threat model. Let me summarize now what we offer you with our threat modeling. First of all, it is a fully automated. All input in the model is not coming from surveys. It's not coming from the discussion with architects or business people. It comes from a running application. So this is the most realistic. This is real, actually. That's what really happening with your application. And that input comes into our tool. We're not involving multiple individuals. Actually, we're not involving anyone. We don't need to talk to your business experts or architects or developers or operation specialists. Everything that they thought, what they planned, is already implemented in this application, and we are observing whatever they inputted into that application. We're observing it, and we're presenting it to you with detailed analysis. That running application fully reflects what they invested into the application, and we can see. The building of the model is practically instant. You saw that Ganesh imitated Log4j attacks, and then in a matter of few seconds, he built that model, the immediate snapshot that could be given to your developers with a recommendation how to fix it. So we're taking a snapshot of a running application, and it takes really seconds and minutes. Maybe for a very large application, it might take whatever, many minutes or hours, but it never takes the 60 days or weeks or days as with the users of traditional tools that cannot create a new update of the model for less than 50 or 60 days. The accuracy is not messed up by human interventions. There is no assumption or surveys. The input into the model comes directly from the real running application. So there is no deviation. Whatever is happening with your application, you can see it now in our model. As to the automation for modeling, the model creation is automated by default. We don't need any additional automation because whatever really is happening there, it's coming into the model and immediately. And controls, our remediation advice, remember that Ganesh shown you on the right-hand side, detected security vulnerability. The advice is to fix this particular detected vulnerability. It's not generic, it's very specific. You are not spreading your efforts to fix everything that might come to your desire to fix. You're fixing vulnerabilities detected in real time by our technology. And our standard prescribed approach is no diagramming, no questionnaires and surveys. Just run your application at your pre-deployment build and test time, and you are getting a model of your application, of your API ecosystem, and your threat posture. That ends our presentation. Thank you very much for your attention. And we have, I believe, about 6 minutes, a little more, to answer your question. So I have 1, 2, 3, 4, no, 5, 6 questions. So let's start with this question. What threat modeling techniques does Avocado use? Stride or Paston? Would you answer it?
Sorry, I was on a mute. Yeah, so that's great question. So our model is based on Stride, whether we can do spoofing, tampering, repudiation, and so on and so forth, right? Which is used by other threat modeling tool as well. And it was easy to us to send it JSON files where we can. If you have like a third-party tool, you can consume that JSON file as well. So yeah, to answer your question, yeah, we have Stride model built in.
Mm-hmm. Good. Let me get to another one. Is this an agent that must be installed on anything that will be included in the models? Where else can the detected attack data be sent for action beyond notification for a model change? Let me at least start answering this question. This is not an agent that we're using, it's a plugin. There is a quite substantial difference. We are installing this plugin on your application server, but unlike some technologies such as REST, we are not instrumenting your virtual machine, your Java virtual machine, or your .NET CLR. We're not running in the system space. We're running in the user space. We are sitting on sockets, on API calls. So this plugin is a simple piece of software. The size is about 4 to 5 megabytes. The installation is automated. It takes about up to 2 minutes to install it. That's one piece that you would install on the servers that you wanna control. You saw it on Ganesh's representations. There's a variety of servers, and typically you need to install that plugin on the server. Once again, the installation is about 2 minutes. The second and the only piece of software is what we call Orchestrator. It's a portal that installed and controls have visibility into all plugins installed in your organization. There, for example, you can set up policies. What else you can do? When you see the model and you want to create, plug it into some other tool, you're creating a standard JSON file, and you can integrate it with the SIM technologies, for example, with Splunk. You can integrate it with reporting technologies such as Tableau, for example. So the variety of integration is actually limitless because it's just a file. Anything else to add here, or I can go to another one? We have limited time.
Oh, only one thing I'll add
Please
is
go ahead.
you don't need any instrumentation with our plugin. You have to enable it. That's it.
Let me go to another. So that's the we answered, the agent we answered. The next one, where the stride does lateral movement fit? Ganesh, you want to answer, or
Can you repeat that question, please?
where the stride? They are asking where the stride methodology for modeling fits lateral movement.
Right. So lateral movement, like just imagine, right? You have data center and you have different application. You have web server, BI server, SQL server, and so on and so forth, right? When the majority of attack happens within your infrastructure, right, you can detect north south bound. There are a lot of like a security product helps to detect north south communication as well as vulnerabilities. But when it comes to internally connected all application, what Avocado does is Avocado monitors all communication between different application server, and based on that we have very deep observability where we can provide the detailed information at the process level, so we can find the thread associated with east-west traffic, and based on that we provide that information. As you probably know, like none of the security product does everything, right? However, for east-west traffic, I think it's very important to analyze those data and find any vulnerabilities associated with that. That's where Avocado plays very important role.
Thank you, Ganesh. Guys, we have two more, at least actually more questions, but we are in the very last minute of our presentation, of our demonstration. I would suggest the following. You have our coordinates, avocado6.com. We are available. You can reach out to us. We'll be happy. Send email to the email address presented there. Reach out to Ganesh or myself. My email is jfeynman@avocado6.com. Well, reach to anyone, they'll pass it to us, and we'll be able to answer it via email or have a meeting and explain. We'll be very happy to answer your questions. With that, there was another question that came in. Thanks for answering my question. Good stuff. Thank you very much for the long answer. With that, we have to finish our presentation. We are planning our presentations, our demos once every month. So next one will be on observability. There is a new technology, actually new market that has emerged, and we are players in this observability, specifically in security observability. And in approximately 1 month from now, we'll do presentation observability, which actually technology that sits behind our application and threat modeling. With that, Ganesh, thank you very much. It was such a pleasure. I enjoyed this presentation. I wish everyone to have a good day, and please reach out to us. Goodbye.
Thank you all.